of binary relation. What is binary? In the realm of mathematics, binary relations serve as fundamental concepts that underpins various branches for the discipline, including set theory, algebra, and analysis. A binary relation is a mathematical construct that establishes a connection between two elements, generally drawn from set. Unlike unary relation that involves a single element, binary relation involves pairs of elements, providing a versatile framework for analyzing and describing the relationship between different entities. Binary relation provide a way to connect pairs of elements. Imagine you have a set of objects like number of shapes. A binary relation is like a magical link between two of these objects, showing how they relate to each other. Think of it as a special friendship between pairs of things. This connection could signify many different relationships, such as is greater than, is equal to, or even is related to. The beauty of binary relation is that they help us explore and understand the connection that exists within a set of objects. Or, formally, a binary relation on set A and B is defined as a subset of the Cartesian product A, B, where each element of the subset corresponds to an ordered pair A-B with A from A and B from B. This abstract definition allows from broad interpretation, making binary relation applicable to diverse mathematical and real-world scenarios. Binary relation play a vital part in various mathematical structures, similar as function, equivalence relation, and order relation. Understanding the properties and characteristics of binary relation not only facilitates the exploration of mathematical theory, but also find practical application in computer science, logistics, and other fields where connection between elements needs to be analyzed and modeled. Concept and characteristic of binary relation. For the first one, pairs and connection. At its core, a binary relation is all about pairs of elements. These pairs could be anything, numbers, colors, or even people. We denote a binary relation between element A and B as AB. It's like saying, hey, there's something interesting going on between these two. The second one, relation in everyday language. Binary relation mirror how we talk about relationship in everyday life. Think of phrase like is equal to, is greater than, or is a friend of. This phrase describes the nature of the connection between two elements. Number 3. Domain and range. The domain of binary relation consists all of the elements that start this relationship, while the range includes all the elements that are on the receiving end. It's like looking at who involved and who affected. Number 4. Reflexivity, symmetry, and transitivity. Binary relation has special characteristics that define their behavior. Reflexivity. If every element is related to itself, the relation is reflexive. It's like saying everyone has a connection with themselves. Symmetry. If whenever A is related to B, then B is related to A, the relation is symmetric. It's a two-way street of connection. Transitivity. If A is related to B and B is related to C, then A is related to C. It's like a chain of connection. Number 5. Examples abound. Binary relations are everywhere. In a set of people, you can have a relation is a sibling of. In a set of numbers, you can have is less than. The possibilities are vast, and they help us describe the relationship between different elements. Number 6. Representation. This relation can be represented in various ways, such as diagrams, tables, or matrices. These representations help us visualize and understand the pattern of connection. Number 7. Equivalence relation. Some binary relations go beyond just connecting elements. They create partition or group within a set. These special relations are called equivalence relations and play a crucial role in various mathematical concepts. In summary, binary relations are fundamental concepts in mathematics, allowing us to explore, describe, and understand the intricate web of connection between elements in a set. As we uncover more of this relation, we gain valuable insight into the structure and nature of mathematical relationships. This is the example for the first one. Set of numbers. Let's start with a set of numbers. Number 2. Binary relation is greater than. We define a binary relation on this set using the phrase is greater than. So, for any two numbers A and B in our set, if A is greater than B, we say AB is in the relation. Number 3. Example of pairs in the relation. 7, 2 is the relation because 7 is greater than 2. 8, 3 is in the relation because 8 is greater than 3. 5, 2 in the relation because 5 is greater than 2. Number 4. Non-example. 3, 7 is not the relation because 3 is not greater than 7. 2, 2 is not the relation because 2 is not greater than 2. It's equal. Number 5. Examples abound. Binary relations are everywhere. In a set of people, you can have a relation is a sibling of. In a set of numbers, you can have is less than. The possibilities are vast and they help us describe the relationship between different elements. Number 6. Reflexivity, symmetry, and transitivity. Reflexivity. This relation is not reflexive because not every number is greater than itself, like 2 or 3. Symmetry is not symmetric because if 7 is greater than 2, it doesn't mean 2 is greater than 7. Transitivity. It is transitive because if 7 is greater than 2 and 8 is greater than 3, then 7 is greater than 3. Number 7. Representation. We can represent this relation in a table or a matrix, showing which pair are in the relation and which are not. In conclusion, binary relations serve as fundamental tools in mathematics, capturing the essence of connection between pairs of elements through concepts like reflexivity, symmetry, and transitivity. They enable us to explore and understand diverse relationships within sets. Whether describing numerical comparison or social connection, binary relations provide a versatile framework for analyzing and representing the intricate web of organization that exists in mathematical structure.